as Mike said, originally I studied engineering, and I left that feeling pretty happy, but I felt I needed something more, and I ended up in a master's program at the Royal College of Art in London, which is not dissimilar to, I think, one of the master's programs you run here, which was really a design course that was specifically tailored for engineers. And I did that for 2 years and was hired by these guys, Dyson. So I'm sure most of you have heard of who they are. And after leaving the Royal College of Art, I felt like, oh, I'm definitely a designer now. This is what I'm going to be doing. So I thought, well, I'll turn up at Dyson and they'll give me a nice design project, and that'll be that. But it didn't really pan out like that. And I guess it never really does. And the sort of things that you plan to end up doing, you invariably don't end up doing. So I got there, and after about 3 or 4 weeks, they said to me, okay, how about you go and set up factories in Malaysia for a bit? And again, it was another, can you go for 12 weeks, and ended up being there for a year. So I spent a bit of time in the Far East setting up production lines, talking with suppliers, not really what I had planned. And I came back after a year and thought, okay, right, well, now I'll get down to design. Okay, and I did that for 2 or 3 months, and they had another project for me that wasn't anything to do with design, and I always had this hankering that, well, I need to be getting back to design, but it really worked in my favor because throughout the time I was there, I worked in so many different areas that by the time I actually got back to doing any design, I had all this other, I don't want to say knowledge and experience, but this different outlook on the other factors that go into designing products. And then shortly after I got my feet into a design project, they came and said, well, can you go to Chicago for 3 to 6 months? I said, okay. And I've been here ever since. And I came to Chicago to work on product reliability, product safety, anything that had to do with a product not doing what it's supposed to be doing. So problems in quality, problems in manufacturing, problems in design, every little, the sort of the dirty end of the design world, if you like. And I did that for 6 years, I think. And I left Dyson about 7 months ago now, with no bad feelings at all, which is the way you ought to leave a company, I think. And then I joined these guys. I joined SRAM. And SRAM, for those of you who don't know, are a bicycle parts company. And they make really everything on the bike except the frame. And they specialize in very high-end, very highly developed road and mountain bike components, predominantly competition components. So you're looking at state-of-the-art road racing equipment. This is a typical time trial bike, I think, that Alberto Contador is the rider. He won the Tour de France last year on SRAM's equipment. So they'll give you a sort of a sense of what their racing pedigree is. But I didn't really join to work on that. I met a guy, this guy here, the guy on the back of the bike. His name is Frederick K. Day, or he likes to be known as FK Day, and he is the executive vice president of the SRAM Corporation. Along with him and his brother Stan, they kind of developed SRAM into the company they are. FK is an interesting guy. I met him for my interview, and he was in shorts and cycling shoes because he just cycled in. It's a bike company, so that's what you get. But around the time of the tsunami in Asia, which was, I think, was about 6 years ago now, FK was kind of moved by that, and he thought, well, we've got to be able to do something. We're a big, wealthy company now, and we ought to be able to do something with bicycles. There must be something we can do. So he flew out to Sri Lanka and managed to source a number of bikes locally, about 24,500, I think, that he sourced locally, had made locally, and distributed them to local people in order to help them get back on their feet after this natural disaster. And it was very successful. But it really turned his mind round to thinking about, well, of course, there's people who live like this all the time. There's developing countries where people are living in to us, what would seem a disastrous way of life. There must be something we can do with bicycles. There must be problems of which we can solve with the bicycle. So he spent some time in in some African countries, predominantly Zambia initially, and started to design and develop a type of bicycle that would be suited to that environment. I'm aware of various schemes and programs where bikes are sent over to African countries from Western countries as donations. And one of the things that FK noticed when he went over to Zambia for the first time were these piles of old bikes by the side of the road, these broken down bikes, all different types of bikes. The problem with when a bike that's not meant for that environment breaks, getting a spare part is very difficult, so they quickly become useless. So the bike that FK developed, here's a picture of it here. It's pretty old-fashioned, as you can see. It's affordable. I mean, you can buy these through World Bicycle Relief for $134, I think, and they'll be donated to someone in Zambia, and a good chunk of that cost is shipping. So the actual part cost of the bike is substantially less than any one of a single component that we would spec on a race bike through SRAM. So it's a very, very affordable product. It's extremely heavy. I mean, this is about 50, 60 pounds, I think. There's a lot of steel in there. And we did try to make it lighter in the early days. But FK had said that when people evaluate the bicycles, they'll pick them up to feel how much steel's in it. So a heavier bike is perceived as being stronger and more robust, even if it isn't. Even if you spent years doing finite element analysis to make it as light as you possibly could, it wouldn't be worth the bother, because people would equate it with less metal is less durable. The design is kind of intentionally old-fashioned. It's an old, based on like a 60-year-old English cruiser type bike. So all the sizings and threads and spacings are all this old-fashioned standard. We'll come to why shortly. The rack on the back was something that we had to design specially. We couldn't find this rack anywhere in the world. It needed to be strong enough to carry the weight of another person. Often in some of the African countries we operate in, the bicycle is used as a taxi. So it needs to be tough enough to have someone sat on the back all day long. Often you'll see bicycles when you're over in, I was in Zambia last year, and you see other sorts of bikes around. You see a lot of very, very inexpensive Chinese bicycles, Chinese-made bicycles, I should say. And they tend to look similar, but we have a term for bicycles like that. It's a bicycle-shaped object. It's something that looks like it's going to function like a bike, but very quickly falls apart and becomes useless. So looks can be kind of deceiving. I want to talk about this for a minute. This is a complete tangent, but when I met for my interview, FK had said, we kind of want this to be the AK-47 of the bike world. And I know that's a rather uncomfortable association. It's something we're trying to develop is a tool for empowerment and social change and helping people get to school, and it seems to be completely opposite to a gun. However, let's just ignore that for a minute and just consider the sort of phenomenon of this weapon. This was designed about 60 years ago by a Russian tank commander. And it's heavy, it's inefficient, it's unreliable, it's got atrocious aim. If you had one of these guns and it was your only option, you'd be pretty concerned that it wasn't going to help you. It's really a terrible thing on the face of it. I mean, if you had a choice, you would never pick this as a weapon. But it's been the dominant weapon of choice in any war-torn region for about 60 years. And the reason for that is it can be made easily out of just about any material you can find. It can be repaired easily. You could probably bury this in a river for about a year and pull it up, and with a quick shake it would still do what it did before you buried it. It's the perfect example of a robust design. It may not be wonderfully good, but it is consistent, and it's effective in that if someone's pointing one at you, you'll take them seriously. And this is really why this weapon has been successful. It has nothing to do with performance. It's simply about the fact that it survives its environment and it's appropriate for its intended use. So if you take that idea and you apply that to a tool of social change and of empowerment and of a tool to enable education, then you've got something very special indeed. Our bike is that's kind of our approach, but without all the military connotations, of course. We're trying to make this bike tough and durable, and by Western standards, this is an inefficient, clunky bike. I mean, I ride these around Chicago, and I'd much rather have my bike, which is much more suited to its environment. But we want it to be compatible with where it is. You'll notice the ground here is this kind of slightly reddish sand, and this seems to be the most abrasive substance known to man, and wherever it lands, it tends to wear metal away very quickly. So this is a very, very unkind environment. And however well we spec these bikes, at some point things start to wear out. We've kind of hit the limit of what we can do with standard parts, which is where I come in. I was hired to develop drivetrain components, which is gears and chains and brakes, and anything that moves, anything that rotates and is under load really falls into my category. It doesn't matter how much money you throw at this bike at this point, you can't buy good enough components to survive this environment as long as we want. Some of the simpler components, not a problem. Handlebars, frames, forks, this sort of stuff, that tend to soldier on for a good length of time. This is a complete tangent, by the way. I do this sometimes when I talk, so I thought, well, rather than just drift off into a tangent, I'll start on a tangent and see if I can work my way back. This is a fairly recognizable image. I mean, everyone knows who that is. But just ignore who it is for a minute and just look at what you see. You see eyes, nose, mouth, hair, and your brain kind of pieces all this together as symbols, and you recognize the face, and you recognize it as a face. Even if you didn't know who it was, you'd see the components of the face and you go, okay, that's the face, I got it. Well, what happens if you invert it? Well, you still recognize it, and you still know it's a face because you've just been looking at it, but your eyes are drawn to it in a subtly different way. You start to notice things that you weren't looking at before. Your eyes just go to different places, and you start to see shapes in different ways. This is your brain trying to work out what it is. There is a point to this, by the way. Here's another drawing. This is a Picasso drawing of Igor Stravinsky. And I've got this up because one of the things you do when you're learning to draw is you'll often copy pictures. This is a kind of a natural thing that you do as a child, or even as an adult. If you're trying to learn to draw, you'll take another picture and you'll copy it. It's much easier than trying to draw three-dimensional real life. And this was a drawing that was given to some drawing students to copy. And the first two were told to copy it this way up. And the next two were told to copy it upside down. And let's see what happens when we've done this exercise. Okay, so here's the original. These four pictures here are drawings that the four students did of themselves. So that will give you a clue as to the level of drawing that these students were at. Very, very basic, very sort of primitive looking sketches of what people look like. These are really symbols of people rather than people themselves. The top two were asked to draw the picture right side up, and the bottom two were asked to draw it upside down. And you can see from the drawings that the top two, they kind of got it. And their drawings are somewhat similar to that, but they're quite close in style to their original drawings. That's how they have perceived what they're drawing, is much in the same way they think about themselves. All of these students would have said, I can't draw, by the way. Some of them were adults, some of them were children. The bottom two drawings are much more accurate. much closer to a finished, the original drawing. And you can see, particularly with this bottom one, the original drawing style is very basic indeed. But while that student hasn't quite got it right, he's been able to see much more clearly. He's been able to represent what he saw much more clearly. Now, why is that? That's because inverting something prevents your brain from seeing things as you think you see them. It allows you to see things as they actually are. It breaks those patterns where the brain is trying to form patterns about what it's seeing. And it enables you to analyze the drawing and reproduce it accurately. It sort of enables you to see clearly. This is something that I think applies to, certainly applies to all forms of drawing and painting and probably design as well. It's fair to say that if you're drawing faces all day long, you'll get very, very good at drawing faces. I've known artists who've been face guys or girls. They've got very, very good at doing one thing because they understand the anatomy of it. They understand, well, if I draw a head slightly tilted to the side, I know the mechanics of what's going to happen to the nose and the eyes. And then you say, well, all right, what about hands? Oh, I'm not so good with hands. And this is an argument of experience over method, because if your method is correct, you can draw anything. And a good artist is able to draw whatever they see. Whereas experience is only really retrospective. You can only really draw what you're used to drawing. But if you develop that method, that becomes far more powerful. And this is certainly true in engineering and problem solving and design. The way you look at things has a huge impact on how effectively you can solve those problems. So how does this really apply to design? Well, here's our bike underneath a grinning child. And, you know, it's similar to other bikes. You know, it looks a bit like other bikes. But when you stop thinking of it as a bike and start trying to define it by its functions, then you think about it in a very different way. So for me, I mean, I have a bike, and to me, a bike is an option. I mean, it's a way for me to get to work if I don't want to take the bus, if I don't want to do this. The function of a bike for this guy is, this is how he gets educated. He has no choice. It's either walk 10, 12 miles a day or ride a bike. So this is, functionally, it's different. It's his link to healthcare. He can get to hospital if he gets sick. It's his distance multiplier. That's its function. It enables him to travel further in a day. And when you start thinking about it in those terms, you start to see the possibilities of it a little bit more. And you're able to think more clearly about any design improvements you want to make. Invariably, we do want to improve the design. This is a slightly grainy picture, for which I apologize, but this is a guy in Zambia, and this is his job. This will be to haul charcoal. This is one of the primary ways in which rural people can make money in Zambia. And he will have about 60 kilograms of charcoal on that bike, and he may ride that for 60 kilometers, which is about, what, 40 miles, something like that. So he's putting a hell of a lot of effort into that bike, a lot of hours going into that bike. So right there, that's kind of a design brief. I mean, you can look at that and say, right, well, clearly we need to do certain improvements to the bike. We actually have a team of these guys in Zambia who we pay just to ride back and forth all day long, which is how we do our durability testing. So they just haul charcoal for us all day long. But we start to think about the functions, and when people talk to us, when we go out to these countries and we talk to people, and they say, well, I really need gears on the bike. So, well, okay, why do you need the gears? You don't really want to stop there. You want to go a little bit deeper and try and work out what are you actually trying to do with the bike. So, well, when I'm on a long flat road, the one gear we have isn't really fast enough. I run out of gear too quickly. And when I'm carrying all this charcoal, I can't get uphill because it's too much load. The gear's too heavy. So, as an engineer, I try and break that down as to trying to explain it in a way that doesn't point me in the direction of any one solution. That's called, it's a slightly long-winded phrase, but you try and describe problems in non-solution specific terms. So you don't want anything to point you in the direction of a particular solution too early, because it will stop you considering other things. So when he says I need gears, I really define that as, well, I need to extend the range of this bicycle. I need to extend its useful operating window. And if you think about it in those terms, then you can start to think about solutions that aren't obvious. Here's another bike here, and this is not our bike, I should point out. And again, I'm sorry for the grainy photo, but the sort of state of bicycles that you see is horrendous. I mean, there's things, people riding around that you would have thrown away 10 years ago here. It's just that what you've got to see when you see a bicycle is, well, as bad as that is, it's better than walking. And that's really the difference that it makes to people. It's simply thought of as a distance multiplier. It's a way to carry more load than you were before. It's a way to travel further than you were before. So whatever you do to this bike, that's really what you ought to be looking to try and do. So another example of that way of thinking, some of you may have seen this before, but it's very cool, so I thought I'd talk about it. And this is, this relates to a huge problem in developing countries of infant mortality. So low birth weight, premature birth, these are all things that contribute to infant mortality in developing countries, and it's a huge, huge problem. Hundreds of thousands of children die in their first day every year because of low birth weight and associated problems with poor conditions. And we tackle this in the West by using incubators, which control the environment the baby's in until they, can develop enough strength to survive comfortably on their own. And if you think about this traditionally, you think, okay, well, let's send some incubators out there then. One of the problems with doing that is the incubators we have in the West are complex, they're expensive, they require training, the spare parts are expensive. So you can send the incubator out there and, it may work for a little while, but as soon as you fly home and leave it, we don't know how to keep this thing running. It's not compatible with its environment. It's not been designed for that way of life. If you think about it in terms of its function, so try and define it by its functions rather than what it is, then you start to think about the problem in a very different way. And a bunch of students and volunteers, I think at MIT, did just that. And they came to this conclusion and thought, well, let's look at the environment. Let's see what else is going on in these countries. And we have a phrase in World Bicycle Relief, the answers are always in the field. So you have to spend time looking at the environment to understand where the opportunities are. And they notice that the one thing that people can keep working are old pickup trucks. People seem, for some reason, manage to keep these old pickup trucks going. And the genius of this team was that they made this incubator, all the functioning parts were old automotive parts. So you look at all the functions of an incubator as to provide heat. Okay, well, let's use the headlamps. They provide heat. You need some sort of cooling control. Well, the fan from the dashboard, we could use that to cool the system down when it needs cooling down. Even the alarms that flash on the, I think I'll go back a slide. These are side lights, indicator lights, and this one too, I think. So the whole thing is constructed entirely of automotive parts. So you can send this to a country, a developing nation, and be relatively confident that this is going to be able to be kept going, because you will find people who are used to repairing old cars, are used to getting hold of old automotive parts, and it's compatible with the knowledge and training that people have in its environment. So this is, a really wonderful example of what you can do when you start to think about things in different terms. Stop thinking about what it is so much as what it does. You can define it by its functions, and it will allow you to think very differently about what it is. So we're always looking to do that with World Bicycle Relief, of course. We want this bike to be compatible. We want it to be part of its world, which is why they're assembled locally. Rather than just airdropping a bunch of bikes in and and leaving, we set up an assembly plant. We set up training programs for people. I talked a little bit about why the design was so old-fashioned. And, you know, getting spare parts in Africa is a problem, but the spare parts that you can get are generally old-fashioned single-speed cruiser parts. So if you go to I don't want to say bike shop because that implies the wrong thing, but here is a little market stall in a town just outside of Zambia. And this is a fairly well-appointed bicycle spares shop, if you like. And the guy that's working here would have people come in and, you know, another puncture, okay, here's a puncture repair kit and broken pedals, cranks, and these sorts of things. And we knew that whatever we wanted to do with the bike had to be compatible with what's available in its environment. So we have just very, very basic set of parts. And we know that this is a huge constraint for us. We can't really deviate from that standard unless it's completely indestructible, because at some point, if you remember the pictures of the people hauling charcoal, somebody somewhere is going to break it. And we want to make sure that when that happens, people are able to bring it back to life. People are able to keep those bikes working. I said that's a fairly well-appointed shop. This is a slightly less appointed station, but it's nonetheless, this is this guy's living. He sits by the side of the road, and if your bike breaks as you're going along, he will be able to repair it and fix it. And he has very, very little, but what he does have is all standard Old English parts. So when you don't need to spend very long in the field before you start to realize that you're really up against it in terms of what you can do with design. When I joined SRAM, my first instincts were, okay, well, let's get the markers out and let's start thinking about a brand new concept. And it's completely the wrong way to go. You have to sort of immerse yourself in the constraints of the field before you can start to see clearly. Just like with the drawings, you have to sort of, you know, really be able to see without forming opinions before you can work your way through to solutions. So this is the economic pyramid, it's called. And this is a way of looking at wealth distribution around the world. I'm not an economist, so I'll probably say all the wrong things. But what we're concerned with at World Bicycle Relief is this part of the pyramid, the bottom of the pyramid, which constitutes, you know, 4 billion people live on less than $5 a day. So there's a huge chunk of people. And there's obviously money down there, but it's spread so thin that, you know, people don't have a lot of spending power. And I think one of the big problems that, a big trap to fall into when you're designing things for people at the bottom here is that you assume you know what's going on. You say, okay, well, you know, people are obviously poor, so they'll take anything. And it's not true. It's not even like, you don't even want to think like, well, what would I be like if I was in that situation? Because if I lived on less than $5 a day, I'd fall apart. But if you've been living that way your whole life, it's a way of life for you. That's not to say it's good, it isn't, it's terrible, but you have to think that these are people with opinions, they're people who have opinions about what they do buy, they're brand aware, they have a sense of what they want and what they don't want. So you have to go into it thinking like they're people, but the big challenge as a designer is you don't live in this world. The very nature of being an engineer or a designer or anything like that is that you've been educated and you're working in a commercial discipline, which means you're employed, which by definition means that you're not, you operate up here. You don't live down there. So you have to rely on your design method almost completely to try and see your way through to solutions. That's not to say that designing for people who are wealthy is any easier. I picked this example of really bad design because it's some of you may know it. This is called the Sinclair C5, and as you can see, it's from the 80s. And I'm slightly cautious about ridiculing it because the guy that designed it is a guy called Clive Sinclair, who is kind of the real deal. I mean, he gave us the first pocket calculator and the first commercially available home computer. So he's something of a clever guy, but this is a real turkey. And you know, one of the traps you fall into when you're designing for people within your economic range is that you're often the end user. You're often the target market. And the big trap there is you can end up designing for yourself. And it's very hard to look past what you want to see what needs to be done. I mean, if you start trying to think about this in terms of its functions, try and see the problem that this is solving, and it becomes very, very unclear. This is something that was heavy, slow, small, extremely dangerous because you're too low to be seen on a road. And I remember when these came out, because I was about 7 or something, and they had these commercials of people in like groups of 5 or 6 driving through these quiet country lanes with trees and stuff, and there are no roads like that. So they were completely impracticable roads, and they were illegal to ride on the sidewalk. So right there, that's a huge problem. It's almost a completely useless product. I mean, it's the sort of thing that as a designer, you understand how it came to be. Someone's like, oh, this would be wonderful. I didn't really think it through. It's a completely undeveloped idea. And it is simply about when you're designing for people close to you, you think you don't have to think that hard about it. And you do. You still have to rely on that method in the same way. Here's a slightly better example of problem solving. And my former employer, of course. James Dyson, the man who founded Dyson, must be 20 years ago now, maybe longer, he came up with this technology. And this was born of frustration, of him using a product. He felt that as he was vacuuming with his expensive vacuum cleaner, it just really wasn't performing as well as it should. It was fine for the first 20 minutes, and then the performance dropped right off. And this was when vacuum cleaners all had bags. Imagine that. And so he opened the bag, and it was covered in dust on the inside, and realized that this thing is basically clogged. The whole inside of the bag has been coated with dust, and the performance drop is instantaneous. And so he came up with a solution that didn't use a bag. The real genius of this was that he understood that this wasn't his problem. This was a fundamental problem with a very widespread product, a product that everyone has, and everyone's overlooked this problem. So it wasn't his flight of fancy. It wasn't something that he wanted to see himself. This was what he acknowledged as being a fundamental problem. And again, if you think about the function of a vacuum cleaner, ignore what it is for a minute. The function of the bag itself is simply to separate dirt and air. And if you think about it in those terms, you're able to think, well, there must be other ways to separate dirt and air other than the bag. And you can start to think more clearly about exactly what's going on. So, in summary here, I'd kind of like to just take us back to World Bicycle Relief and the bike for a minute. The process by which we design these products is the same, irrespective of whether we're designing them for people who live with next to nothing or people who live with everything, just like us. This really comes down to design method and a cautionary tale about experience, because, and this will certainly be relevant for you, because you'll be going into a workplace with very little experience, and experience is always retrospective. It can only tell you about what you've previously done. And whenever you do something new, I think whenever I do something new, I ought to be developing my method rather than adding to my list of experience. I ought to be challenging the way I think about things, thinking about things in different ways. You'll always meet people who have done something for 20 years and think they always know best. And often your greatest ally is a lack of experience. It enables you to, forces you to think methodically. The big takeaway I got from working at Dyson was certainly that being creative certainly doesn't prevent you from being methodical. And engineering, design, problem solving, all these things, they are not trades of experience. These are trades that relate to method and technique rather than knowledge. Experience is not ability. And that's a useful thing to say in an interview, by the way. And whether you choose to work at the top or the bottom, I like to think of things in terms of value. So there's certainly value in designing for people with plenty of money. You know, the only reason the differential exists between the top and bottom of the scale is that we've had a lot of exposure to new technologies. It's important that whatever you do adds value, and I think that's what we do with World Bicycle Relief. So that's about all I had to say. I'm going to turn it over to questions. Sure. Well, what I used to do, once you come out of design school, your first instinct is to say, okay, well, I'll reach for the pen and start sketching, and that's the first thing I don't do anymore. I guess the first thing you've got to do is you always, professionally, you always go into a problem with some background. I was hired to do this job. All the stuff at Dyson came with some sort of brief, and the trick then is to listen and spend some time thinking. And I like to go through and try and define what I'm doing as almost as a list of functions. It's not a rigid list, but when I was joined to work on the gear system for World Bicycle Relief, I thought, well, okay, I know you said gears, but I think what you mean is extend the range. The first thing you want to do is open it up as big as you can. You don't want to bring in any limiting factors too early. You only want to define the problem. You want to go as deep as you possibly can, and you should be able to define a problem, if you think about it enough, in one phrase. You should be able to get to one phrase that really defines what you're trying to do. And certainly in the case of the gear system, it was, how can I extend the range? And from there, with the case of World Bicycle Relief, it was imperative that I spent some time in the field. And really, for the first, I want to say, couple months, I didn't really design anything. I looked at our existing technologies. We knew that the solution that we will ultimately have, we will use our manufacturing routes and our suppliers and stuff. So you need to understand what your constraints are. You need to construct a framework, if you like. You can only know the things that are knowable at the time, but it's important that you work out your framework. One of the ways you do this in engineering is you generally do this a little later on in a project, but you create what's called a failure modes and effects analysis. But the first half of that analysis is defining all the functions of the product that you're trying to analyze. And you can do this without having a concept. You can actually list what it needs to do before you've even got an idea. So that's part of your framework. You're just trying to establish what it absolutely has to do, and the rest you can work out as you go along. But what you don't want to do is to get, as designers and engineers, you get attached to ideas. It's kind of a natural thing. Ownership of ideas is a huge problem in any design and engineering setting. Ideas, at least from my point of view, should be thrown around, discarded, and treated fairly irreverently. An idea is not a concept. It's something that needs to be processed. So, got my thread now. But it's just about trying to establish a framework into which you can put an idea and test it against all these known factors. So it's quite methodical, and it kind of goes against what you feel intuitive as a designer in a sense. But it's your engineering side that comes through. Sure.
You mentioned that coming up with
Yeah. Right. Well, this is a challenge because I went out to Zambia last year and I took a prototype. And when I've tested prototypes in the West, we're all used to seeing new things, and people are generally very receptive to new ideas. And so when I was at Dyson and I tested prototypes, people would be very vocal about what they thought about it. I like this, I don't like this. The problem with developing nations is people who have nothing aren't used to being vocal about things. So you have to work a little harder to interpret what's going on. And again, I think that's an advantage because there's a tendency in research, when you're researching an idea, that you use the research as instructions. You listen to people and you hear what they say and they say, I want this. Oh, okay, well, I'll design that then. And Henry Ford famously said, well, if I'd asked my customers what they wanted, they would have asked for a faster horse. So there's a cautionary tale about the use of research there. You have to, it's not about doing what people say, it's trying to understand what people really need. So you can listen to people and it may be that what they actually need is something completely different. It's more challenging, certainly when you're much further away, and I'm lucky in the fact that SRAM are more than happy to send me to Zambia a couple of times a year for that very purpose, to ride bikes with people, to talk to them and generally get a feeling of what they're trying to do. And you don't necessarily need to interview people. You need to go with your eyes open, just like with the drawings. You need to start seeing without your own experiences getting in the way. So it is challenging, but you do have to look. You have to look hard and you have to interpret what you see, if that makes sense. Sure. Well, the ultimate plan is, I mean, there's the World Bicycle Relief Program, and that really is a way for us to take, that's a non-profit organization. It's self-sustaining, but it's funded by donations. So donations come from the West, and they buy bikes that are then donated to school kids and care workers and people trying to ferry medicines around and get see sick people, and it's a way to connect villages and stuff. But we also sell the bike. I mean, we're very keen that this needs to be a sustaining project. This is something that needs to work without our involvement at some point. So it needs to be something that is of value to the local people, that they are prepared to spend the little money they have on this because they see the value of it, because it's something that genuinely enriches their lives. We do face certain challenges with the selling of it. I mean, we talked a little bit about how people are, even though they're living in poverty, they're still brand aware and stuff, and they're very concerned that if they're buying a bike, they don't want to have a bunch of charitable branding on it because it suggests that it was given to them. So when we sell them, we tend to sell them without all the World Bicycle Relief branding on them. But we are keen that the product is something that is going to be rather like the AK-47, is something that is self-sustaining within its environment. That's the long-term goal. Sure. Yeah. Well, the bike we have is already made in China. That the actual parts are made. There is no way to manufacture a bicycle in Zambia yet. You have labor that you can use for assembly, but you have no supply chain. You have no manufacturing capability. And the way that these bikes become affordable is simply by volume. It's an economies of scale thing. You have to turn a lot of them over in order to make them worthwhile. If you were going to set up manufacturing in Zambia, the cost would just go up massively initially. We assemble because that's kind of the easy bit, but the actual manufacture does happen in China. It's the only way we can get it affordable enough. One of the problems is we're trying to keep the supply chain as small as possible. You're always trying to, anything you can do to limit the costs. I mean, when we talk about the cost of the parts on this bike, you know, you're talking about, oh, the pedals, they're too expensive, they're 30 cents. You know, the actual level of price on these parts is just minuscule compared to what we're used to looking at, but cumulatively it all adds up. So China, for now, is the manufacturing side. Oh, sure. Well, that's what I'm working on at the moment. I've been working for SRAM for 7 months now, so I'm in the middle of developing prototypes. And this is another point that I'd make, is that you have to use the field to validate those designs as well. You're always looking to learn. You have to be open to completely changing your mind on things. So it may be that I've spent 7 months working on getting a prototype multi-speed system in place, and it turns out that people don't see the value of it, and in which case I'll have to completely rethink it. But that's okay. That's the process. You can't get emotionally attached to the idea. You have to be prepared to discard it. It's one of the challenges we have when we're trying to explain the benefits of the bike. You know, we may be able to clearly see a benefit of something, but if the end user doesn't, then it isn't beneficial. So you have to rely on that testing. It's not a push. You can't simply push things into there. You have to put them in, see how people get on, and you have no system of training or no system of advertising or of explanation. You just have to drop the thing in and see if people work it out. Because, you know, there's no TV, there's no internet, there's no way to communicate the benefits of things like advertising campaigns. You just have to drop them in and test them. So it's an ongoing project, and we are prepared to reevaluate as we need to. But as with all design projects that I've ever worked on, whether it's stuff with Dyson or anything I've done, where you end up is never where you think you're going to end up at the beginning. So you have to be open to that. Sure. Oh yeah, there's I don't know the full business plan of how World Bicycle released, but I know we've been involved with microfinance and things like that, and it's one of those ongoing challenges, and it affects any end of the economic scale. Is this argument of cost over value? Now, you know, you can put our bike next to the cheapest possible bike you can find, which would, you might be able to get a bike for $30, you know, that cheap. I mean, but, you know, again, it's that thing about, well, they look about the same, but if after 2 or 3 weeks, if all those functions are broken down, then it's not functioning as a bicycle anymore. It comes back to thinking about things in terms of their functions. But it's always a challenge when you're dealing with people who just have so little money, is getting this point across, well, you could buy that, or you could buy this, and this will last, you know, 4 years. But it's the same problem right throughout the economic scale, basically. But we do a bit of, we have been involved with microfinance because it is a way for people to buy those bikes, and it is very successful. But people know that our bike is more expensive than some of the bikes you can find around. But in the long run, you're building that reputation for something that is perceived as something that's going to add value. I mean, with Dyson, it was kind of the same thing, because for years, Dyson did no advertising, and they would quite quickly, you know, start making a lot of money very quickly, and it all went through word of mouth. But in a country where people just aren't connected that well, and no cell phones, you know, people don't move out of their village much, word of mouth takes a lot longer to spread around. And that's really the only way you get to communicate the value of what you're doing, is through people telling other people about it.